Welcome to Glaciers and Groundwater. In this lab, you're going to use a combination of topographic maps, Google Earth, and a few experiments in class. So make sure you've read everything and you have the appropriate documents printed out. You can follow along while we run through what to do. In this portion of lab, you're going to be simulating some differences in groundwater by using this stream table setup. So what you'll do is first make sure that your hole is plugged. Still keep the tape over it over here. Make sure that it's plugged, but still have the bucket here to catch any water that might leak out, because it can happen. And then you're going to want to shape your sand in the way that I have here. And it might be a little bit easier to shape it if it's a little wet. That way it can move around a little bit easier. So you're going to have a straight channel running down the center. You're going to have a lake at the top where your hose is going to go into. And then you're going to carve in a series of holes that go as far as you can get them down to the bottom of the plastic. And then you're going to have a little lake up front that's a little bit bigger than these other small lakes. So you're going to make sure that this pattern is the same as what is shown in your lab. That way you can just sketch what happens right on that diagram. So if you would like to put some toothpicks in, you can do that in various places. But the main thing that you're going to be looking for are the changes in the levels in the lakes that you have in here. Sometimes it's helpful to have a few points of reference, like these toothpicks throughout here. So once you get everything set up, you're going to turn your water on, slowly at first. And then you're going to let this run. So we're going to let that lake fill up. Now you don't want it to fill up so fast that it overtops and spills over into this river. You want it to fill up and then start to slowly ooze out into these lakes through the sand, so the groundwater actually moving. So I'm going to turn this up a little bit more. So we have some water coming out. And you're going to let this run. Now make sure someone's watching this so that this doesn't totally overtop, which it's starting to again. Turn it off a little bit. And basically you're going to keep doing this, let it run until you see the bottom lake here fill up with water. You let it fill for a while. Note the changes in the lake levels throughout. Note what happens in this river here. Does it fill with water? Does it not? Does it start to erode? Yes or no? And then mark those changes on your lab. And once this is filled up to a point that's pretty high in your table, you're going to keep the water running. You're going to drop a drop of food coloring in one of these lakes. Note which lake you drop it in. Make sure it's one of the upper ones. Mark that on your lab. And then you're going to unplug, rip the tape off, unplug your stream table, and let the water drain. And then you're going to keep note of what happens to all these lakes. What happens to the lake level? Does it rise? Does it fall? And then you're going to note what happens to your food dye. Make sure that you mark the time that you enter or you drop your food dye into your lake, because if you get the chance to see that dye move into another lake, then you can calculate the rate of groundwater motion, how fast it's moving from one place to another, because you'll have your time that you entered it, the time that it pops up in the next lake, and then you can measure the distance between those two lakes. And if you don't have a chance to see the groundwater move using this food dye, what you can do is just sketch on your lab manual what you think happens. Which way do you think the water's going? How fast do you think it's moving? So for this portion of your lab, you're going to be simulating two different glacier types using two different simulations, and we're going to have some silly putty. So make sure you take it out of its container, work it in your hands for a while to get it nice and loose so it's easier for you to form it into the different shapes. First one that you're going to be doing, we're going to put it in this Petri dish, and you're going to roll it up into a nice ball and then put it in the center of your dish, maybe squish it down a little bit so it's nice and on there. And then you'll take a marker, and you don't necessarily have to use a Petri dish, you could also use an overhead sheet, but make sure you have something you can draw on and it won't come off. So make a circle right around the edge of your blob, and then put your toothpicks into it and a whole bunch of different locations. And you want to try to make sure that they're sticking as straight up in the air as you can. Just kind of put them all around. And then you're going to leave this experiment for the majority of lab and come back to it. So the next one that you'll do, take your other piece of silly putty, form it into more of a log shape. And then our little track here, this PVC pipe that's put in an inclined angle, already has a couple lines drawn on it for us. So if yours doesn't, you can draw your own. You're going to take your little log-shaped bit of silly putty and then place it in your PVC pipe and then kind of squish it so that it takes the shape of that PVC pipe. And in this case, I've got it set at the bottom pretty good, but my top line isn't quite right, so I'm just going to make another one here so I know where the dimensions are, where the top is and where the bottom is. And then I'm going to take my toothpicks and put them in here. I want to do a straight line down the middle. This is just what glaciologists will do. They'll put kind of a T shape. Put a whole line down the center, and then they put a couple across. So then you'll leave both of your experiments for the rest of the lab while you finish your stream table experiments and the map questions, and then come back, see what's changed, and make your sketches and answer your questions. So if you have any questions, please email me, and I will see you in lab.